So this lesson's on 6.A.1, which is the distance formula. It's called As the Crow Flies, which we'll go through in a second. So the scenario here is that it says, suppose that the city in which you live has a system of evenly spaced perpendicular streets forming square city blocks. So that's what you can see on this map. The map below shows your school, your house, which is located 2 blocks west and 5 blocks north, and you should fill out your compass as north, east, south, west, so that you know which way to kind of move left, right, up and down. And then it says, and your best friend's house, which is located 8 blocks east and 1 block south of the school. So all of that is kind of labeled on this diagram. So today for these video lesson, I'm gonna kind of just go through this. Had I been in class, you would have been able to pretty much discover this on your own and then practice it. So it says, how many blocks would you have to drive to get from your house to your friend's house? And then you're drawing the path that you would drive. Now again, when you're driving, we cannot go straight across somewhere from your house to your friend's house. You have to instead think about driving left, or going straight and then turning and then going straight again. So we want to figure out how far are we going to go east, because we're going to go to the right from your house to your friend's house, and then we're going to figure out how far down we're going to go. So I'll go across like this from your house across until you're right on top of the friend's house. So you're going to go across like this. And then straight down. So you want to label how many units that is. So going across here, that would be 10 units. And then going down was 6 units. So if I count how many that is, 10 and 6 would make 16. So it says draw the path, that's what we did, that we would drive, and then calculate the distance. So the distance would say 16, and we're doing everything in terms of blocks. Now it says, well, what if you could use a helicopter and fly straight from your house to your friend's house? So now this time I don't have to go, straight across, then turn and go straight. I can this time just drive or fly directly there. And this is kind of where the saying "as the crow flies" comes from, where that's going to be like the straight distance you could take if you were like a bird, or in this case a helicopter, flying straight from one to the other. So it says draw this path, then try to figure out the distance. It says as the crow flies, so that as you're going right from one point to the other, you don't need to go left and right and up and down. We are going to round to the nearest hundredth of a block. So if I look at my diagram again, it's as if I want to go straight from your house to your friend's house. So we're going to connect from here all the way across like this. And to get this measurement, if you notice hopefully that there's a right angle here, because that would be a right triangle, and we can use Pythagorean theorem to help us get that distance. So we have 10 squared plus 6 squared are the 2 legs. So 10 squared plus 6 squared, and that would equal, I can call it x squared. You can use your calculator to help you here. This would be 136, and you would square root it. So this comes out, because we have to round to the nearest hundredths, it's approximately, and we'll write d for distance. You could write x because you're representing that measurement as x, but I'll just write d for distance, and it comes out to approximately 11.66 if you round to the nearest hundredths. I'm sorry, to the nearest hundredths, and then the units are blocks. All right, so now we are still working with this diagram here, but it says now establish a coordinate system. That's kind of like where we have our x and y coordinates, and there's an origin, and it wants us to use school as the origin, which we kind of did already when I first drew in this 5 and the 2. But if I imagine that is like my coordinate system here with 0, 0 as school at the origin, it says what would the coordinates be for your house and for your friend's house? So for your house, you're going left 2 units and going up 5 units. So remember, when you write coordinates, you always write x first, then y. So for your house, I'll label that with an h. We will do -2 and then a +5 to go up. Whereas for your friend's house, which I'll label with an f, you're going to go right, there's right 8 units and then down 1. So 8, -1. So again, you always go left or right first when you write a coordinate, and then your y is how you go up and down. So then it says, how could you use these coordinates that you just identified to calculate the distance as the crow flies from your house to your friend's house? Instead of just counting the lengths and then like working through using how we did Pythagorean theorem to get this, where we had to calculate those distances. If we just had coordinates and we didn't have a diagram to work with, instead here's what we could do. We basically would have to find the difference between our x values, find the difference between our y values, and then we would apply the Pythagorean theorem to that. So if I wanted to figure out how far away -2 and 8 are, I can kind of visualize it and just say, like from the origin, for example, 0 to 8 would be 8 units. But if I'm going from -2 to 8, that's a total of 10 units across. So that's where I get the 10 from, which if you want to show work for this, which you don't need to, but if I was to show work for it, it's kind of like saying 8 minus a -2, which would be 10 blocks going horizontally. And then from the y values, 5 and -1, do the same thing. 5 minus a -1 would get us to 6. And then you would take those and we'd put them into, again, Pythagorean theorem. So 10 squared plus 6 squared, just like we did above. That would help us find x squared, but then again, you'd have to square root that to figure out what is the actual distance. All right, so it'd be the same idea. It would still obviously come out to 11.66 blocks, but it's just another way of looking at it rather than just having to draw the right triangle and then take the legs and square them and square root the whole thing. That's where the distance formula actually comes from, because what we kind of just did here says write a formula that will show the distance between any 2 points. So anytime you have 2 coordinates like this, which we have x1, y1, x2, y2, which is our general points, you can use the distance formula, which says d equals, and then there's this big square root all the way across, and inside of the square root would be, like we did here, we took the x's and we subtracted them, the 8 and the -2 there. So we're going to subtract our x's, x2 minus x1, and we square it. And we squared it again because we're applying the Pythagorean theorem to that. Then we could do the same thing but with the y's, like how we did 5 minus a -1. So we would do, in addition to that, we add y2 minus y1, and we square that. So this is the distance formula, and this is something you're going to need to memorize if you don't know it yet. But it's using, if I have a diagram like how I have on the left here, and it just shows me 2 points that I'm connecting, and I want to find the distance of those 2 points, that's what I could do. Now it's, again, the same idea as what we've done before with using Pythagorean theorem. If I want to just create a right triangle, the 2 legs I get will be the same as just subtracting the x's squared and subtracting the y squared. But again, this is a quicker way to do this without a diagram. In case you don't have a diagram and you just know 2 coordinates and the question will say, find the distance, you could then just substitute and find your answer. So now we're going to move to just practicing using this formula over and over again. So let's jump over to the back page. And at the top here, we have an example of 2 coordinates, and we're asked to find the length of the segment. It says give an exact length and an approximate length, rounded to the nearest hundredths of a unit. So exact means you should not round your answer. You should leave it with fractions or square roots or anything to make it exact without having to pick up a calculator to round it. So let's see with the distance formula what this would look like. So d equals, remember the distance formula says take the square root of the x's subtracted and squared, and then the y's subtracted and squared. Now it really doesn't matter the order that you subtract your numbers, because when you subtract numbers and then square them, the sign remains the same. So if I had just done -1 minus a -4 and squared it, versus -4 minus a -1 and squared it, I would get the same exact answer. So it's not like how slope formula was, where you had to be careful about which one was y2 versus y1 and then x2 and x1. Here, it really doesn't make a difference how you subtract, but just make sure you're only doing x's with x's and y's with y's. So I could do something like -1 minus a -4, and I want to square it. Just be careful with signs. That's like the biggest issue we see with this unit, is just students not being careful with subtracting and adding. Then we have the -4 and the 2, but again, you can switch the order. So if I wanted to do -4 minus a -2, I could do that, or -2, or I could do 2 minus a -4. It really makes no difference as long as you square it. It actually would have been better to do 2 minus a -4 if you're trying to avoid negatives altogether. But here's what we have. These negatives will be positive, so we're looking at the square root of 3, negative 1 plus 4 is 3, and squaring it is 9. And then negative 4 minus 2 is negative 6, and squaring that is 36. That comes out to the square root of 45. But that's not an exact answer just yet. I do need to simplify it. And again, in simplified radical form, this perfect square sitting inside 45 would be 9. So that would be the square root of 9 is 3, and then 5 would sit inside. So this is considered an exact answer. And then when you round it, you pick up a calculator and you type in either square root of 45 or 3 root 5, and that comes out to 6.71. And then you can put a U for units if you'd like to, but you don't have to. As long as it doesn't tell us the measurement that it wants it in, then you wouldn't have to do that. Here's another example. It says a lake is shown below. An island is located at 4,5, and a boat travels in a straight line from 2,0 to the island. If the boat travels at a speed of 20 miles per hour, how many minutes does it take to reach the island? And it's just telling us here that for every unit is 1 mile. So when we're done, our units, we'll make sure our answer will be in miles for the distance. And then for the final answer, we need to make sure it's in minutes. Okay, so we have a little bit more work to do here other than just finding the distance, but let's start there. Distance between 4,5 and 2,0, because again, it's the island and this boat that we're traveling from. So straight there. So we're going to start with the distance formula, and again, the order here doesn't matter so much, just subtract your x's. So I usually will try to do biggest minus smallest just so that it ends up being a positive number. And then this one, same thing, 5 minus 0. But you can switch them and you would still get the same answer. So here's what we're looking at. The square root of 2 squared would be 4, and the 5 squared, it comes out to 25. This is the square root of 29, which does not simplify any further. There's no perfect square inside. But I'm going to keep it, you can either round it at this point because you're about to then deal with multiplying, or you could keep it square root of 29 for right now. Because the main idea here is our answer is in miles, so this is miles. I want to write my answer in terms of minutes when I'm done because I have to account for the speed. So a couple of ways you can think through this. If the units are 20 miles per hour is how fast the boat is going, I can take square root of 29 miles and divide by 20, and my answer will be in hours. Now I don't want hours, I want minutes, so I will eventually have to then convert it to minutes. You could also make a proportion. Some people like proportions here, where you would say square root of 29 miles over x miles, because you're trying to figure out what the units would be in terms of miles. I'm sorry, not x miles. This would be, if I put it here in terms of hours. So I have 20 miles per hour, per 1 hour, and then you would say x hours because your hours are kind of lining up on the bottoms, and then you would cross multiply and solve, and it would be the same thing as just dividing, but this might help to see why is it that we are dividing by 20. So the answer I get for this will be again in hours, and so this comes out to approximately, because you do have to round here, it was about 0.26. I'll round to like 3 numbers. Let's do 0.269. But again, that's in hours. I want my final answer to be in minutes, so I need to take that number and multiply by 60. So let me do that over here. 0.269 times 60, because there are 60 minutes in an hour, and again, we're trying to convert from hours to minutes. That will give me my final answer of how many minutes it will take, which is about 16 minutes. And I rounded to just the whole number here so that I didn't have to have decimals. But so this one got to be a bit more complicated because after using the distance formula, we had to do a conversion to using the speed of that boat. So let's try a few more, same idea. The next one says we have a line segment. Now this looks complicated because there's not really many numbers or variables, but you again approach it the same way. If you're trying to find the length of the segment, you're just using the distance formula with these x values and y values. So let's start off with big square root here, and then subtract your x's. Now again, we have a 3e and a 2e for my x's. I would prefer to subtract the bigger one from the smaller one. We're still squaring that. Then you take your y's, now they're different units altogether, so it really does not matter which one you subtract first or second. But here's what one way you could have written it, or you could have written g minus 2f for that part as well, and flipped those around as well. So let's try to simplify as much as we can until we are looking at the square root of something, if it simplifies that far. First of all, 3e minus 2e would just be 1e, and when I square a 1e, that's just e squared. For 2f minus g, now the only way to kind of simplify this a little bit further would be to think of it as writing it twice and then using FOIL or box method. So for example, 2f minus g, 2f minus g. And then this is where you do FOIL or box method to kind of go further. So let's see here. The rest of this stays the same. Still an e squared, still the big radical, but this would give me 4f squared because I have the first terms. The outer and the inner for the O and the I for FOIL would be multiplying these guys together, so the negative g and the 2f, and then the negative g and 2f again. So that would give me a negative 4, either gf or fg. I just put it in alphabetical order. And then finally, negative g times negative g would be a g squared. So this is all kind of just hanging out inside of that radical. You can leave your answer just like this and you're done. That's as far as we can go. Or we could move things around, like if you wanted to kind of put it in alphabetical order almost, you could do that. But there's really no need because this is as far as it goes. And you cannot try to simplify like the e squared to become an e, because whenever there's plus or minus signs inside of a radical, you can't simplify any further. Now, if it was just the square root of e squared, then you would write that as e. So in that case, we would simplify further. All right, here's one more. The hardest part of these, because distance formula on its own is not too difficult, is the algebra that kind of comes along with it, or being able to work with simplifying radicals, decimals, fractions, all of that good stuff. All right, so let's use our distance formula one more time here. We're almost done. We want to subtract our x's, so we have a 5 root 3 and a root 3. So I would, again, take the bigger number, 5 root 3 minus root 3, and we're squaring that. And then we have our y's, negative 4 and negative 5, and we're going to square those. So negative 4 minus a negative 5 squared. And then simplify until we get to a point where we can't simplify anymore. So 5 root 3 and minus, you can put a 1 there if that would help. 5 minus 1 would be 4 root 3. So when you subtract radicals, you have to make sure that their radical parts are the same. Like if those were both not 3's, we would not be able to subtract like I just did. When they are the same, you just grab the numbers in front and subtract them, keeping the radical the same. So it's still being squared. We'll keep going. Then we have negative 4. This would be plus 5, which comes out to 1. And squaring that is just a 1, which you could write as 1 or 1 squared at first. Then to keep simplifying, the 4 root 3 squared. Now you can use a calculator to help with that if you want to, but you have to make sure to use parentheses around that whole thing. Just like you see it here written, you'd have to type it into a calculator like that. But to be able to do this without a calculator, here's what we would do. 4 squared is 16. The square root of 3 squared, because you have to square each part of this, would just cancel the radical and leaving with just a 3. So 16 times 3 is what I get there, which is 48. And then I had a plus 1 still. That comes out to the square root of 49, and that's 7. So after doing all of that work, we finally got down to a point where it's just d equals 7. All right, so that's saying the distance between those 2 points is 7 units. All right, and we're going to finish off with this bottom one here, which is kind of where we're going to be headed with why we start with the distance formula. This whole unit deals with connections to algebra, and we kind of use what we learned in Unit 5 with all the different shapes, and we're going to eventually talk about something called a coordinate proof, which will show us different shapes, again, like rectangles, squares, parallelograms. This first one is a rectangle, and it tells us that. That's why we know here that there's 2 pairs of opposite sides congruent, also 2 pairs of opposite sides parallel, but we know that that's true for a rectangle. We also know there would be 4 right angles here, which doesn't really help me with distance or the area and the perimeter here. But in order to find the area or the perimeter, I would need to know the distances here. And no, I can't just count units because it's not a straight line up and down, so that's why I have to use distance formula. So it'll help here if you label your coordinates. So we have 5, 2 for this one up in the corner. Then we have for this bottom one, 2, -1. And then the one down at the bottom, you can pick whichever one you're gonna work with, because you really only have to find one length for the short side and then one length for the long one, because then you can just double it. So this point here is sitting at 9, -8. All right, so now that we have those 3 points, we use the distance formula to label finding those points. If it helps you to kind of label them A and B, that would, instead of having to, or you can label the coordinates if you'd rather do that and say this is segment A, B, or whatever. So this is for, first of all, let's start with A. So to find the distance of A, starting with the distance formula, just subtracting the x's, subtracting the y's. So 5 - 2 squared, and then the y's are 2 minus a -1 squared. And we're simplifying here. So we get 3 squared, which is 9. And this is also 3 squared, which is another 9. That comes out to the square root of 18, which can be simplified. And you should always write in simplified radical form, because when we write the area and the perimeter, we want an exact area and perimeter, which means I don't want to round. So this would be 9 and 2 are the two factors here. So that comes out to 3√2. So that's saying this little guy here is 3√2, and so is the one across from it then. And then we have B. So we have the square root of, same thing, but we're just going to use the coordinates here. So we have 2 and 9. So we'll do subtract the x's, 9 minus 2 squared, subtract the y's. So you have -1 and a -8. And squaring it, then we simplify. So we have 7 squared, which is 49. And -1 minus 8 would give me a positive 7 squared again, which is 49. That comes out to the square root of 98, which simplifies to 7√2, because the square root of 49 is sitting in there times 2. So you always want to, again, simplify until you get down to the most simplified answer. Now we have 3√2 and 7√2 for that one and that one. So we have all 4 sides here. This was 3√2. And so for perimeter, you're just adding up all the sides. For area of a rectangle, it's base times height, or length times width. So you're just multiplying those 2 measurements together. So let's go ahead and do area equals base times height, which would be 3√2 times 7√2. And so 3 times 7 is 21, and then when you multiply the radicals together, square root of 2 times the square root of 2 would be the square root of 4, which is really 2. Now you don't have to show all this work to it, but you just have to get down to a point where you have 42. Remember, when units are not provided for area, you have to put a u squared. So the area of this rectangle comes out to 42 u squared. And then find the perimeter as well, which just means add up all the sides. So there were 2 sides that are 3√2 and 2 sides that are 7√2. So this comes out to 6√2 plus 14√2, and altogether that's 20√2, which again we can combine because the radicals were the same. You have to put a u for perimeter. Since it didn't tell me what the units were, you have to include that u. And that's pretty much it. If you do have questions, bring them tomorrow. Homework tonight is just to start on 6.A.1. Right now the answer key is not up on the website, but I will work on getting that in as soon as possible so that you can check your answers tonight.